All right, guys, welcome back. So good news, I have got the booklet. So the really teacher has delivered it into my little box so that I can actually help you guys with some of these questions if you need help with. So far, hopefully on page 7, so you've done the first side over here. So if you haven't done it, you really need to get that done. And once you finish that, have a look of the answer and see if you got it correct or not. If it's incorrect, and then you will need to send me a message and ask me how to do them. Okay, so it's very important. And this topic is internal, and we only have one test, so there's not a lot of practice for you guys to do. So you need to make the best use of this booklet and all the questions over here to make sure that you understand everything. And that is very, very important. Okay, so make sure you spend some good time and going through them. And if there's anything that you don't know how to do or got it wrong, use a red pen to emphasize it. And because you see, I always get 3 different color pens over here, my blue, my black, and my red one, so that I can highlight the important things using a red pen and then point it out to people. Okay, so same for you guys. Okay, so today we're gonna be looking at radioactive decay. So however you call it, you can call it radioactive emission, or you can call it radioactivity. Okay, all right, so in my notes I've called it radioactivity. Okay, so what is radioactivity? You might have heard of this word before, right? Radioactivity. Normally when we think about radioactivity, we think of something really bad. Okay, so why do we think radioactivity as something really bad? Because they could be harmful to us. Okay, but are they also useful? Where do they come from, and what are they? So in this lesson, we're gonna try to work it out. So radioactivity is basically a byproduct of any kind of nuclear reaction, okay? So first, we want to define what is a nuclear reaction. So you've learned about chemical reaction last year, okay? So chemical reaction happens at the electron level, okay? Say this, like magnesium, like burning magnesium. When you burn magnesium, magnesium is gonna lose 2 electrons. And where does these 2 electrons go? It's gonna be gained by oxygen. So you got magnesium atom, oxygen atom. One losing 2 electrons, the other gaining 2 electrons, and then bam, they can join together because they're very happy with this arrangement. And then one become magnesium 2 positive, and one become oxygen 2 minus, and then become magnesium Mg oxide. Oh, okay. So that is a chemical reaction, and all chemical reaction happens this way. You either gain electron, lose electron, or sharing electrons. Okay. So, but for nuclear reaction is happening inside the nucleus. So the nuclear means the nucleus, and the nucleus is in the middle. It got proton and neutron. If there is any change of proton and neutron, and then this is a nuclear reaction, okay? So for example, if you got 6 proton and 6 neutron in the middle, that's a happy nucleus. I don't care what's happening to the electrons because we're having a nuclear reaction. And then bam, it breaks down into 2, okay? Or maybe boom, it shoots out a proton, or boom, a proton has changed into neutron, or neutron changed into proton. So anyway, if there's any change inside the nucleus, then we say there's a nuclear reaction that has happened, okay? So later in the topic, we'll see a lot of different nuclear reactions, and then how do they happen, why do they happen? So, but for now, we need to know that, okay, if there's a nuclear reaction happen, and then that can give out something called a radioactivity, okay? So what is radioactivity? There are 3 types, okay? So 1 is the alpha decay, 2 is the beta decay, 3 is gamma decay. It normally only shoots out these 3 emission, radioactivity emission, okay? All right, so let's say, okay, what is the alpha decay? Alpha decay gives out an alpha particle. So what is the alpha particle? Alpha particle is a high-speed helium nucleus, okay? And then what is the beta decay? Beta decay is actually just a high energy electron. So beta particle is an electron, high energy electron. And then gamma decay is just electromagnetic wave. So both alpha and beta are particle. So, but gamma is not a particle. Gamma is just energy. It's kind of like light. So you got UV ray, you got colored, all the different colors, rainbow colored, you got microwave, you got Wi-Fi signal, radio signal. These are all type of light ray, okay? So, and gamma ray is a light ray as well. So we can't see it because the energy is too big, too strong. So but it is a type of light, okay? And then coming back, important things for you guys to remember about these three is, so alpha particle is helium nucleus, so it got 2 proton and 2 neutron. So we say alpha 2,4, or you can say it's helium 2,4, okay? So it doesn't matter because it's helium. And then it has positive charge and it's very heavy. So when we were talking about Rutherford's gold foil experiment, so we used the alpha particle to shoot because they're very dense. I want to see how it interacts with the thin gold foil, okay? All right, and then the second part is it has very strong ionization ability. So the reason why it has very strong ionization ability, first I need to define what is ionization. Ionization is when an atom captures or releases electron to become an ion. Okay, so that's the same definition as chemistry one. So for example, if you have an alpha particle coming through air, if it interacts with air, alpha particles really want these 2 extra electrons so it can balance the 2 proton. As you know, helium atom is very stable. Helium is the most stable one, so it's called the noble gases on the periodic table. So for helium, it really wants that 2 electrons, so it's going to grab electron from anywhere. So this is the reason why the alpha particle is very dangerous. Say if alpha particle come and shoot onto my skin. If it shoots onto my skin, it's going to grab electrons from my skin. And as you know, all these organic matters, they're joined together by these chemicals through electrons. So you got the DNA structure you've learned from year 11 biology, and we learned year 10 as well. So you know how they have the base, one join another, So TAGC, right? TAGC, like boom, forming those chains. But if the electron got stolen from them, and then there's going to be a change in this arrangement, so there's a high chance of causing cancer. So cancer is once this chain changes, when say a cell is duplicates the cell instead of duplicating it normally, because the coding, the electrons inside has been changed, and then it could start to grow cancer, and then the cell kind of just grow a lot of them, or the cell could be dead, or so there's many possibilities. So if you're only exposed to 1 electron or 1 alpha particle, probably doesn't matter. It's only going to change one, only going to steal 2 electrons from your body. So but if you experience a lot of them, and there could be a problem, is because it's going to steal a lot of electrons from your body, and then the chemicals inside your body will not be able to work properly. Okay, so anyway, and then it has the lowest penetration ability. That is because the alpha particle is really heavy. And so once, say, you have a piece of paper, even the piece of paper can stop the alpha particle. So the alpha particle is going to come and hit the paper and then stopped, okay? So what is the usage for alpha particle? Alpha particle, it can travel a few centimeters in air. So all these details you will need to remember it, okay? Very important. Okay, so for example, alpha particle, when we have we don't have it in this room, if we have smoke alarm. So normally smoke alarm is the old types at least are using alpha particle. So how does it work? So the smoke alarm have a detector and an emitter. The emitter shoots out like small amount of alpha particles going into this one. So it's just gonna constantly shoot out alpha particles because there's a little bit of nuclear reaction material inside here, constantly shoot out into this one. So if there's any smoke in this room, the smoke will start blocking the middle. Okay, you can't shoot through because the smokes are over here, and then this one will not receive alpha particle. If it's not receiving alpha particle, and then that will make a noise to say, oh, there's a big fire in the room, there's too much smoke over here. So that's how smoke alarm works, okay? So there was one year, there was a question asking, okay, why do we use alpha particle? It's because alpha particle does not travel very well. That is the reason why we use it. So beta and gamma travels really well. So if it travels really well, the smoke cannot stop it. So that's why it's not useful. It's always going to have the the beta particle and gamma particle, okay? So gamma ray, not gamma particle, gamma ray. So, but for alpha particle, smoke can stop it. And the other thing is say, oh, well, why is it safe for us to use alpha particle in this situation? And then the reason why is because like the cover it's made out of plastic, so even if alpha particle gets out, the cover will be able to stop it. Okay, and even if it's get out of the cover, then alpha particle can only travel in air for a few centimeters before it's gonna interact with the air, so it's going to grab two electrons from somewhere. So the helium nucleus, which is alpha particle, is going to turn into helium gas. Okay, so some question was asking, oh, why is there helium gas present? That's because the alpha particle is helium nucleus. Once it steals electron from something else, and then it's going to become a helium atom. Okay, all right. So and for that is the penetration ability and ionization ability. There are two reasons why it is the highest ionization ability. One is because it has the most amount of charge, because it has two positive charge, and the other one is it has the highest kinetic energy. It will be able to knock the electrons out of a normal atom. Okay, so that I didn't write it into the notes, so I don't think that's been tested before, but if you should write it down as well. Okay, so two reasons. And okay, let's look at beta. So beta is negative charge. It's very light because it's electron, and then it has high penetration ability. Electrons are very, very small. So and when it goes really, really fast, it will be able to shoot through things very, very easily. And because atom is mostly empty space anyway. So and then the next one is, so in air it can travel 30 centimeters and can be stopped by 5 millimeters of aluminum. So if you use aluminum, you'll be able to stop it. But if you use plastic, it doesn't stop it. Okay, so it has a lower ionization ability compared to the alpha particle. So which one is more dangerous for us? The alpha particle is more dangerous because it has higher ionization ability. Okay, but beta particle has higher penetration ability. So that means we're more likely to expose to it. And okay, and then the last one is a gamma radiation. Gamma radiation is basically like a really, really strong UV ray, right? We talk about ultraviolet ray. So if we go get suntan under the sun for too long, and then our skin get roasted, that's because of the UV rays. So gamma ray is even stronger. It's much stronger than UV rays. Okay, so electromagnetic wave is not a particle, only have energy just like light, travels at the speed of light because it is a light. Okay, and it does not have any charge because it's not a particle, and then it has highest penetration ability. It can penetrate through several centimeters of lead. Okay, so very strong, and lowest ionization ability. And then okay, so gamma decay, like we use gamma ray for some situation. For example, if we're making an aluminum sheet and say we are making a boat or whatever, like we want to make this thick of aluminum. Okay, so what happens is sometimes aluminum gets too thick, sometimes get too thin. How do we make sure that it's always this thick? So what we do is we use a gamma radiation. Let's pretend this little light here is gamma radiation. Okay, and when it shoots out, there will be a detector over here, and then you put the aluminum in the middle, and then so if aluminum is this much, say maybe this is how much, say 100 is how much gamma ray you're gonna receive, and then so if you're receiving less than that, that means it's too thick. If it's too thick, it will receive less. So then we'll tell the computer, oh no, your the product you made is too thick, and then you make it thin again. Once you make it thin, they'll oh, now it's too thin now, so you want to make it a bit bigger as well, because the number over here is too big. You're receiving too much beta particle from gamma particle from there. Okay, so then you can adjust the level. Yeah, but obviously you can use beta as well, but you cannot use beta if the sheet is very thin, say, because it can penetrate. It can be stopped by 5 millimeters of aluminum. Say if you're doing 1 millimeter of aluminum, then you probably want to use beta particle to do it, because if you use gamma's penetration is too strong, so it just passed right through them, and then it's not useful anymore. So that's why we use beta decay if we use making very thin sheet of say iron or aluminum. Okay, so if it's plastic, you probably use a beta particle as well. So depending on the question, what is they asking, and then you're gonna go try to justify it. Okay. All right. So last concept we want to talk about is called background radiation. So background radiation is a natural radiation that happens around there. So we have a called Geiger's counter. So if you have a Geiger's counter, beep beep beep, you'll hear the beep, and that beep we call it count rate. So it means how much. It's just a unit, and we use and how much radiation we receive. So if I took the machine out right now, like it will go like beep, and after a while go beep. After a while, it's just receiving some radiation from like around us. They are naturally happening like materials. So even in our body, the most of the carbon atom we have is carbon 12, but we have an atom called carbon 14, and carbon 14, there are less of it, but it is not, and it's not stable, but it is there, and it will give out a radiation, so to become carbon 12. So in this way that yeah, so there's natural radiation happening around us, okay? All right, so background radiation, normally they just give you one question, and it's highly likely to be a very difficult, probably just some explanation question. And so, yeah, so that's the whole topic over here. So as you can see, the question, there's quite a bit of question for you guys to practice. So have a try on page 7 of the question. Oh, and by the way, on page 6, they give you a lot of data. So if you ever see something, you don't know how many proton and neutron or like they have, and then it's given to you over here. So say, if you say krypton, and then you go have a lot, okay, 36, so that must be proton is 36, and then the mass is 92. So then you minus those two numbers, then you'll be able to get that number of neutrons, okay? All right, so for these questions, it's actually quite difficult. So I would say have a try and then have a chat with someone else if you guys struggle with it, and then let me know. If you say, oh, sir, I want you to slow down a little bit, you're teaching a bit too fast, let me know as well. I can give you guys a lesson for just like, you know, practicing some questions or asking some questions, okay? And yeah, oh yeah, one other thing is radioactivity. We also use radiation in cancer treatment. So if you become a doctor, you could become a radiologist, and then say if someone got cancer, instead of going into the body to cut the cancer cells out, we can use radiation to kill the cancer cells. Okay, so that's one application as well. Okay, that's all I can think of, and if you have any question, send me an email, and I'll see you in the next lesson. Bye.